it's just been easier just to do it live. Hope I don't screw it up and not have to go edit and then upload. If I get rambling for 20 minutes, and that's at least 20 minutes, I gotta like watch again just to upload. So for review, for anybody that doesn't know what this thing is, this is the next Frankenstein I'm working on, by the way. But carrier unit, carrier high wall, right here. It's blowing out ice cold air again. Guess that kind of tells you that I already fixed it. But this is a carrier high wall. The outdoor unit is a Friedrich package, what they call package VRP, variable refrigerant product. It's basically a VRF in a package. That's why it's a Friedrich controller, because it's controlled and it talks to the unit out there through data. And then I had to take like the coil sensors and everything and hook them up to out there, because I took off the evaporator section of that package, vertical package unit. It goes in hotel rooms and whatnot, in closets. And this was an older one. I acquired it for free, made it work, put in like some circuit boards, and finally found one that worked and did some stuff. I got it to actually work when it was a package unit. The blower was on top. And maybe while I wait for a few more people to connect, I'll go show you the parts I took off of it, just so you kind of see. Oh man, the Goodman just started. You guys hear that? That's not me. That's a piece of shit Goodman there. Anyway, it's a mess back here. I'm live. I can't cut. VRP unit. The covers off of it. It's a complete. I actually got this one working too. There's the inverter board. These have full power factor correction. So it takes AC voltage. Might as well show you guys this anyway so you can see what I did to the unit out there. AC power goes in, it's rectified to DC, but it kind of, I think on the rectified side, it then has these two transformers, and it basically takes the 190, the voltage range on these is 190 to 290 volts AC. Anything in there is acceptable, or 208 or 230, no problem. But it takes it, and it takes the power, and it basically does a DC to DC right off of the rectified AC to charge the capacitors, the DC bus, for the actual inverter output. That DC bus, doesn't matter if it's 190 volts, 208, 230, 290 volts, it doesn't matter. 430 volts DC at the DC bus, no matter what, because that's just, it's actually a DC to DC switching power supply. Does it off of the sine wave, but rectified sine wave somehow, or might be doing it right off the AC. I don't know. Well, it can't be, because I hooked DC up into it before, high voltage, and it powers up. It just errors, so it doesn't like it, but it doesn't blow it up. But I was trying it again. That's what happened today. Well, I broke the other one. So this is a full one altogether. This one also has a reheat coil in it, so it's a little extra complicated. The one over there, I go, I'm going to take this top whole big section off and just use it for a condenser unit, and I'm going to pipe it to a high wall that I had, another of these high walls. So I made that work. Here's the inverse, inclined fan, whatever, out of that other one. I took apart the coil. It's all actually here. I just pinched it, sealed it up. I could actually put it back together. Coil, fan, the heater, which I didn't need, and some other stuff. All the brackets. Pretty, they're high tech. I mean, for what they are, they're way, compared to replacing a PTAC with these, it's the technology is like way overkill. It has everything. It's full inverter driven. The fans, both fans, freaking compressor. It's a 1-ton unit, and I found out that actually the full speed is actually 16,000 BTU, so it's oversized 1 ton, which didn't work to my favor when I was trying to power this other one off of a transformer and everything. When it went up to high, when it was hot, it was like it cooks my transformers, and I cooked my other transformer I was using as a step up, or I would have ran it off 120 volts, and it did work off 120 volts, and it worked off my inverter just fine. But now it's just plugged back into the 230 volt plug. It works fine. So now we're gonna get to what I did tonight. I screwed it up, but not permanently. Obviously, it's already working again. I was just going to see, could you do a voltage doubler on this? I don't know. Maybe I'll fuck it up. I don't know. Let's just try it. So I found some big capacitors I had. They were already actually soldered together like this. And I just put some high voltage, various diodes I had on there. And you have to do them. And basically it takes and charges up one part of your AC sine waves charges these capacitors, and then it goes the other way, and it winds up putting like this, and it basically charges up the next set of capacitor to each time it has the one polarity of the sine wave. It's basically putting them in series what it already charged up, and then plus the next sine wave, you know, from the AC power, and then the next bank of capacitors, which would be those in there, are double what you would get. So it's 170 volts DC out of 120 volts, and then it's like 330 volts from 240 volts input. So I need to get the 300 plus volts, you know, in there. So I did this. It kind of worked, but it just didn't like it. But when I first tried it, I was smelling something, and then I realized I forgot that I had added a transformer in here to power my electronics for my microprocessor, and you can't put DC voltage to a primary of a transformer. It's got to be, you know, alternating current or pulsing DC that's controlled. So other than that, you just put steady DC, and it's just a long piece of wire, and it's a short to the DC source when you do that. So it smoked that transformer in there, and then it didn't work at all. No fan inside, because I have a microprocessor in here that I made. You can see it. I had to take off this other cover, but I've shown it in past videos. But it's taking the speed command signal from the main unit's controller here that was going to the fan I took off. The fan's a big diameter, you saw it, and it runs a slower RPM. And I now have a carrier high wall that runs a small diameter fan that runs a lot of RPMs. And each has a tachometer. So when you send a voltage to the electronic fan motor, an ECM, and it starts running on that 2 to 10 volt, let's just say, for example, DC, you get that variable voltage depending on the command, analog output. The fan turns, it has a tachometer, pulse, 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 pulse. Well, the pulses at full speed was about 44 hertz on the original fan motor to get this to expect it to know it's going at the right speed, and it adjusts and kind of, you know, does its thing. Well, when I would get the right speed of high speed on the little fan inside, it was like 300 hertz. So it was like way too fast of a pulse coming back for speed reference. So it would say, you're going too fast, so it would keep reducing its speed command until that fan would stop and this would fall. If you didn't hook up the tach, well, I didn't like that because I had no tachometer coming back, meaning the fan isn't turning, and it kept increasing the speed, and I would just go to full highest speed it could go inside no matter what it commanded, or, you know, what the unit was wanting to do anyway, and it would eventually stop for failed fan. So I had to take a microprocessor, and it reinterprets the speed signal to the right one to get the right speed inside. Then when that worked, I had to take the tachometer, the frequency coming out, read the speed, which you read by the gaps in between. It's basically an interrupt, and it's like, how long did it take? And you can calculate that to your speed, and then I generate a new speed pulse output. Basically, with some subroutines, I'm doing both functions with one microprocessor on a board, sending the right speed reference and sending the right frequency back that this board expects. It's actually true and correct in a way, because, you know, when that fan's at half speed, it gave the right frequency. You know, it's proportional still. You know, its full speed was about 44 hertz, and I could read my interrupt, which is moving too fast to read, but that's the pulses coming back, generating an interrupt every time. I just have it there for diagnostics. And then my signal out, my pulse width, and it creates, which is about 180 out of 255, 8-bit word, you know, and it's doing it. Yeah, GN, I killed it, but it's working again already. I just blew up the transformer. Reading the text comments there. So, anyway, that was a lot of work to make that work. I made all these boards myself. This little adapter board, even there with the little ribbon cables, I made that. Heat shrinked it. It's just it plugs my cable, which is these white cables. I have coil temperature sensors, and then my speed command and my tachometer coming back. And it's been working for many months perfectly. It's just that it's a 230 volt system. I want to move the unit into that room inside now, and I also want to run, a system runs off 120 volts. So, yeah. I've almost been tempted just to buy a freaking little 120 volt mini split. They sell them for like 150 bucks for like, you know, 3/4 ton or something. So, anyway, I got to go find another transformer to stick in there besides this little one, but I have it run off 120. I need one that's going to accept it, the high voltage. Yeah, it's working fine, so that's it. Gree units, yes, Gree units and Mirage. They're both about 450 to 500 bucks. For that price, if it blows up in a year, you just throw it away. I could almost just get one. It's just that hooking it up with my water heater would be screwed. If I got one, it would be like, leave this heat pump the way it is. This is my heat pump heating up my water, and it's been working for like 2 years. Other than I recently put a smaller rotary compressor I bought on here, used, and took off the one that was on it to put in my next Frankenstein. And this one's smaller, pulls 200 watts less, and it's actually still heating the water, just a little slower, but nobody really complains. We get it, I mean, it recovers just like the water heater would recover off the 4,500 watt element, except for it does a little longer, but it's running on 800 watts to do it. So I could leave this I might just do that even. The easiest thing to do is just leave this working. Still haven't put it on a nice shell. It works. And then just have a separate thing cooling and just keep them separate. But I have this hair up my ass where I think I can like do a bunch of crazy shit and make one unit cool my room and heat the water, which is gonna have to do some weird shit because in the winter, you know, and like right now this is the evaporator. I turned this condenser to an evaporator but it just takes heat out of the outside air and blows cold air out here, doing me no good. I could be cooling the space right now with the same electricity that's heating the water. That's fine and dandy for the summer, but in the winter, you don't want it to cool inside. It freezes you out. So I'd have to like make a dual evaporator unit out of the next one if I do that. So it'd be outdoor evaporator, indoor evaporator for the summer, and then switch to the outdoor one. Always rejecting heat in the water heater, but I think I was going to series the heat exchanger, which is here for the water heater, to where it goes through a condenser coil loop afterwards, and that way it can kind of knock the head pressure down just a little bit. I'll do it temperature-based modulation for fan speed, and then if I'm cooling and the water heater's at an absolute high limit to where it's going to overheat the water heater, I could put a high limit safety in there where it just stops the pump. No more pumping water through the heat exchanger, and then my outdoor fan loop would just speed up its fan and run like a normal condenser. I think that would work actually really good, so I'm tempted to do it. It's just that it's going to take longer to get it done, I think, and get me some cooling in that room. So anyway, so today I had a hair at my ass, wanted to hook up a voltage divider circuit to see if it would do it. It powered up all the lights and everything, but I smoked my transformer, and even after I hooked up another one to 120 and then hooked that back up to voltage doubler, I was getting like a low voltage fault. So, and it could just be that it doesn't have a zero crossing detection, or that it's just not the right voltage after all. Like I said, it goes to rectified DC, and it goes through some, you know, the little wizardry that thing uses with its pulse width modulation through two toroid transformers this thing has on the board to make the 430 volt DC bus that it then feeds to the inverter drive. Inverter drive drives the compressor and that fan, and then evaporator, you know, was integrated electronic fan, which just had all electronics in it, gave it a speed reference and had a tachometer backwards, which is the same way that, you know, that unit inside works, and that's the way I was able to interface them. I just had to manipulate the signals. So, getting ready to put this back together, put another transformer in there. But, to show you guys the new Frankenstein project before I end the video. See what the messages are. 2 small transformers, you could put them, let's see. Well, enough. I could buy a transformer for the price of a transformer that's enough wattage, which is, I need 1 point, because I was reading the wattage. This Friedrich, when it goes to high speed, is 1.6 kilowatts, 1600 watts. It's, my transformer I had was only 1000 watts, so it cooked them, and then I cooked the other one, so it was like shit. The price of those transformers new, and those were free to be used, I got. They were just power convenience outlets from some carrier units that were not used, that we took out of some rooftop units. I used them in reverse. They're not intended to step up. They were made for step down, so that's probably another reason they had issues, but it worked until I let it run too long and overheated them. To buy one of those transformers new, 2000 watt one, right, to be enough. And only 2000 watts when it first kicks on, and when it modulates down, it's like less than 1000 watts. But it'd be like pushing $1,000. Well, for that, I could go buy a whole nother, you know, inverter, 230 volt one, and just slap that on and run the system. But again, the units, I guess I didn't mention this, you know, I did in my clips, so I'm not going to use, but one reason I'm trying to also modify all my AC units on the side is to make it more room to back my trailer into the side behind that RV gate. Right now I have to unload my trailer, then push the trailer in by hand. It barely fits, squeaks by all the AC units between the wall. So if I move the units and put all these skinny little mini split type units back there, I could get some room. So that means that Friedrich unit would have to go too. It's too big, it's huge. So right now I took out the inverter compressor. I think it's laying right there. It may or may not be good. There was either that or the board was bad. It was giving me weird faults, and I think that's why somebody stopped using this unit. It's not that old. So this is a capacitor rotary. This is the one that was heating my water for 2 years. I went through 2 winters with it and everything, but then I just put a slightly smaller one in there and took this one out. So my water heater heat pump's still working, just on the slightly smaller one. This one's been working. You see I kind of foamed it. I wanted to hold in all the heat I could just so it put it into the water as efficiently as possible. So I'm going to pipe it in. This is a heat pump. I'm going to take out the reversing valve. And I'm going to run the liquid line over. And I think I'm going to add a second metering device. This one I'll leave in here. It's going to the indoor unit. I'm going to have to control this myself with my own microprocessor, which I'm pretty confident I could do. And then I'm going to split this coil because this is a 1.5 ton unit, so it's like double almost what I need for coil. I'm going to take it and make it into 2 circuits. And you can see it is in 2 halves. I'm going to make the top half be an evaporator, I think. And it's going to have a second expansion valve go into it. And then this will be the suction, and I'll tee this suction with this suction so they both go to the compressor. And you've seen stuff with 2 evaporators. You just tie all the suctions together, and what it is when you're not using one, you just drive the EXP to the closed position, and it's like a pump down solenoid at that point. So then, like, this one will be closed, and it'll be using the high wall right there. I've already kind of redone the thermistors and have it ready so I can run it to the outdoor unit. I have a microprocessor modulating the expansion valve, feeding it. But the wizardry will be in the winter when I don't need cooling, but the water heater is going to still need heating. It actually runs a lot longer when it's heating, 50-degree water instead of water comes in at 90 during the summer. So it'll freeze me out in that room, taking the heat out of that room when I want to use the room. So I'm going to want to turn off the cooling in that room and just let the computer and stuff heat me up in there. So it'll wind down this one, and I put it in the other mode, and then it'll basically switch from summer to winter mode, and I'm going to have my microprocessor start modulating the other one, which is going to be this top half of the coil, I think. Or I might use the bottom half. Maybe that'd be better. No, top half. The water can run down on the condenser. So, so I'm going to split this into 2 circuits, and then this will be an evaporator. So in the winter, it'll be like the normal heat pump, taking like it is now outside for the water heater, just taking the heat from the outside air. And then I'm going to take this bottom section, and I'm going to make it into a condenser. And what I'm going to do is a series condenser. It's going to go through the water heat exchanger, and then it's going to go pass through this coil. And then what I'll do is, like in the summer, I'll just put a thermistor on there and modulate the outdoor fan. When the water starts getting really hot, towards 130 degrees, it'll still be, at least 130, liquid line. Then I'll probably try to drive it down a little bit, so it'll modulate this fan just a little bit and bring it down a little more, be subcooling it before it goes as liquid into the indoor unit. And then during how should I say, at the times where I'm running it for cooling mode in the summer in here, and the water's already as hot as I can let's say I'm going to put like a safety switch in there, and like when it's below that high limit, it'll allow this pump to run when the unit's running, but then when it hits like 140 or something, like a high limit, the water really fucking hot, I'll probably have it flip to where it just stops this pump, and then takes it out of the circuit. And what will happen is, since there's still a thermistor out here on the liquid line modulating the fan speed, it will just speed the fan up, and it'll be series pass, hot water, heat exchanger, which no water's running through it, so it'll just come almost full temp right to the coil, and then the fan will just speed up and be a normal condenser. I think it'll be some cool wizardry to make. So I don't know. It's gonna take some work, and the only thing about doing it right now is I really want cooling. So I don't know. Almost tempted just to kind of hook it up real simple now, just to have cooling and not and just maybe wait till summer's over, and then like make it into the hybrid. It just depends how fast I think I could build it. So let me check the texts before I comments before I kind of wrap this up. This Friday. Get one of those ERV heat pumps and pasteurize it. I'm not sure what he means by that. Unless it's a brand. I built a heat pump pool heater with a 5-ton Goodman. Oh, I think you were saying that in the other video off a customer's house. That's the first thing I ever did to try this, besides a water source heat pump, was I took a Goodman heat pump I took off of someone's house and I put right on the hot gas coming out. I just left it all hooked up. I just ran it through that heat exchanger and then right back to the liquid line instead of having the indoor coil, right? And then just pass water through it. And then I heated up a bunch of water really fast because it was like a 4 or 5 ton unit. Heated up a lot, the water really fast, which is 20 amps, 5 kilowatts almost, it's, you don't need it that big. As I've proven, I'm able to heat up my water with 800 watts right now. Did I blow any of the FETs on the board? Oh, you talking about out there on that unit? No, that unit's running right now. I changed it. I only smoked my transformer, so it's ice cold. It's blowing. It's blowing right now. It's blowing through here. It's probably 100 and something in my garage. I don't know what that is. This is just sitting here. It's not even in a direct path. Come on, focus, you son of a bitch. I think that's 100, and I think that's like on the 80, so it's 90, whatever. But it's not even blowing directly on that. That's just here close to it. So 100. Wait, 120, 100. No, I think that's the 80th degree. No, yeah, 40, 60, 80. Yeah, it's like 82. 82. With this sitting here and that fan's not turned on. It's the force of this air. So, oops, get that back. So it's probably over 100 in my garage, and it's blowing like 82 at this point right here. Just pushing through the fan. It's not on. That would be on, but it's working. I didn't permanently blow up the Friedrich. I just killed the transformer. That's it. So, yep. So that's the idea with this. Just this ain't gonna be a variable speed compressor anymore. I really don't think I need it because it's so small. It's so reliable. And I already know it runs off my solar charger. This will be off grid, of course, running off of solar and charged up lithium battery up there. It'll like everything in this room. If anybody hasn't seen these videos before, all this lighting, computers, everything I turned on in here that I use, this freaking fridge, the heat pump for the water heater, that's all running off of this, which is off of some backyard extra solar. I have on-grid solar that's grid tie, and then I have this that's standalone, and it's going to be running the AC up here and everything. So the thing is just to kind of heat the water with the same energy it's cooling the room with, so it won't have to run too much on its own to heat the water, and it'll always be kind of cool in the room. Also, each time it has to heat water, it's kind of one thing is helping the other type of thing during the summer. It's gonna be awesome. So, check more messages. I used a water source heat pump too, but I couldn't winterize it. Yeah, so I don't know if you guys watched a couple years ago, I was experimenting. I took a water source heat pump and set it on this shelf when this shelf was in this space in here, which is what I stole to expand and make this. I actually had it hooked up, ran off 230 volts, made it controller to the water. It worked. And then I tried hooking solar up it directly just to see DC power directly into a VFD would work. And it did, but I never kept it wired that way. And then as you guys know, if you watch some videos like last summer and stuff, I was running a high voltage from my backyard panels right into a VFD on my one 3-phase unit that has a VFD on it. And it kind of helped run it during the day when the sun was up, but it wasn't storing any energy at all or doing anything much with it when the unit wasn't running. Then I tried to just parallel in a bunch of lead acid batteries, but you saw what happened to those. Eventually did kind of overheat some. Let me turn this thing off. Yeah, so shit happened. So now then I took the remaining batteries when I had this and had it set for 48 volts, and it was enough. The remaining DC batteries or lead acid batteries were enough to heat my water like maybe once, and then it was running off at utility power after that. But ever since I went to lithium batteries, and they're still up to 55.6, ever since I went to lithium batteries, I've never seen this thing, hardly ever seen it even get down to its 48 volts nominal. I think maybe one time I was running a lot of stuff out and people took a lot of showers, but I've never seen it in the last like 2 or 3 weeks since I've had lithium Maybe it's been a month. I don't know. I have not ever seen this thing run those down and go to utility power. So, yep. But anyway, I got to get wrapping up out there before the sun goes down all the way. Got all the panels off. I just want to give a little update. Just wanted to do it live, just to not have to edit, all that kind of stuff, and then upload. Just this is easier. And people can interact a little bit, but see some Frankenstein stuff coming up. Right now, I'm like still in the part where I was just kind of engineering my controller. I don't remember if I already showed you guys this since I went live, or was in my clip I didn't use, but this is a test project to see if I could run a stepper motor of an electronic expansion valve. Here's a cutaway I made, and here's the needle, and I can move it. There's the needle winding in. You're looking at the stepper motor upside down, so that would be going down, which is actually going up in the unit and opening the needle, and then you could go the other way. And I'm using pretty low resolution, 255 steps, so it takes 255 individual pulses to go from full close to full open, which I probably just gonna leave it there. I don't think I need any better resolution. I could change this to where it does so full steps do half step, quarter step, 8 step, 16th step, which is where you kind of modulate the voltage between each of the poles of the motor to kind of like start increasing one where you're starting to lower, and then you kind of shift your in between the magnetic poles of the motor to get more increments. But I don't need that. I'm not like running a servo to run like some precision mill or anything like that. It's just winding a freaking EXD actually open and closed. 255 possible points between open and close I think is enough for what I'm doing. They're probably doing a little more resolution than that from the factory, but that's what I'm going to do. The other reason is it's exactly a byte, an 8-bit word in programming, and if you go I want more resolution, more steps, I'd have to go to a 16-bit word, which goes from only 0 to 255 as your steps. For 8 bits, it goes to 0 to like 65,000 something, whatever, 250, which is 255 times or 256 times 256. Don't need to deal with those numbers when I don't have to, so it's way easier to stick with 8 bits, which is 0 to 255. 256 steps actually, so if you count 0, it's enough for me. But anyway, yeah, I can reuse all these boards I made. I was practicing my mill. I made a bunch of these extra boards, and they all work. Already has the plug for an LCD, has buttons even on it to do stuff. Oh yeah, and I can zero that anytime I want. I forgot what I was doing with that button. But anyway, it's cool. I just have to basically make different ribbon cables, and everything's here I need to make this be the EXP controller. And I just have basically a stepper motor driver board here that I'm messing with. And I'll just have to make a circuit board now for that to plug into with some ribbon cable connectors like these, and just wire it up and plug the two together, and I have a freaking stepper motor driver for expansion valve. I even have my voltage dividers made for 10K thermistors, so when I plug in like these kind of 10K thermistors, it will read the in and put output. This was outside air temperature and the coil temperature for my other project, but all I have to do is repurpose those and write the subroutines for that, and it will be my superheat. It'll like I think I was explaining before, probably in the video clips I didn't use, but basically what you do is you go to a starting point, and then you're gonna start looking for correction. You're gonna wait a few minutes, and you're like, this is the coil temperature and this is my suction temperature, that's superheat. So you're gonna start modulating to get the right superheat, and then what you do is right when the unit stops, you write that position into memory, and then you wind down the expansion valve and just close it. Then on the next call for cooling or for heating the hot water, the evaporator, is gonna open right where it left off. It's going to be close enough that it works pretty good, but the superheat's going to be off, and then it's going to start modulating. After a couple minutes, it'll start adjusting, and then you make an adjustment, like say wait a minute or two, and then make an adjustment like every 30 seconds or something. I'm just throwing that out there, subject to change, but that's basically all I need to do to make it work, and we'll start adjusting. And I just have to write some subroutines to stop it, and then might have to do some wizardry to switch from one of these to the other, from winter to summer, if I go that route. It's kind of a lot of work to get it running when I really want this room to start really cooling. If I close the garage and turn this fan on, it has been tolerable kind of in here. It's just that that thing stays at full speed and it's not off grid. So it's running on grid. That's not the point. So, all right. Well, I really do need to kind of end the video just to get wrapped up. So I say it once, say it again. Like, subscribe, share, do all that stuff. And I'll get some more Frankenstein updates coming soon. Catch you guys later.